Hello everybody and welcome to the videos. Today we're going to make an ultimate beginner's guide to SQL in about 10, 15, maybe 20 minutes. After this video you should have everything that you need to get going and running your own SQL queries with your own data and feel confident that you know what you're doing. So we're going to start from scratch, go over the most common functions, what they are, how they act on your data, and do some live SQL coding together. And the goal is start with the basics and we'll get a little bit more complex as we go on. So let's get started. So SQL is aka a structured query language, and that is the most common way that people who work with data access and interact with their data that is stored in a database. So SQL is the coding language that you use to access data stored in a database. So let's get into it. Okay, so we're going to start by going to this website called programiz.com. Then we're going to click on SQL. We're going to click on the SQL editor, and this is what we're going to use as our base data. Here is a free SQL editor with 3 data tables loaded up to it, and we're going to use this data and this editor as our playground for learning SQL in. So let us begin. Most commonly, when you work with data in a database, the data in the database is going to be stored in rows and columns. So columns will show you the name of the variable of the data that you have in a column.
And rows will show you the full data record, which is indicated by the row number, or aka index, that it falls in the data table.
So let's start with this customers table. Here we have 5 columns: customer ID, first name, last name, age, and country. And we have 6 rows. So the first row is the header, and the header just generally represents the name of the variable that you're referencing. And when I mean variable, for example, I mean first name. So first name would be the variable, and everything below first name would be the values that represent the data, would be the values that represent the true data. So the data here would be John, Robert, David, John, and Betty. And then the row numbers here luckily correspond with the customer ID. And so row 2, which is actually customer ID 1, because the header row doesn't really count, we have John is the first customer, Robert is the second customer, David is the third customer, and so on and so on. And so with this data set, it's kind of nice and easy. It's like, this is a nice 5x5 data set, so it's kind of small and manageable. Usually in work, the data sets that you're dealing with are going to be much, much larger, sometimes even millions or billions of rows. Okay, so we are going to use SQL, the coding language, to interact with and manipulate all of the data in these 3 databases: customers, orders, and shippings. One last thing to note is there are many different variations of SQL. There's MySQL, PostgreSQL, Snowflake SQL. There's a whole bunch of SQLs, but really for about 95% of all things, SQL follows the same context. So MySQL can get a little bit different, but generally most databases operate off of PostgreSQL, and that is going to be the most common one that you will usually run into outside of MySQL. But just know, for the most part, if you're writing in PostgreSQL, you can pretty much write in any other SQL too, with maybe a few different variations. And so let's begin with the most common operator in SQL, and that is going to be the select statement. So what select means is it is usually the beginning of all SQL statements. It really means what it sounds like. You are going to select the data that you want from a given database. And in the code syntax, the way that would work is we select star. Star corresponds to all. So we're going to select all from what now? We're going to select all from a specific data table. Let's begin with the customers table. So we're just going to look at the name of we're going to look at the name of the table. The name is customers. Copy and paste that in. And so we're going to say select star from SQL. And that means select all from SQL. And what all means is select all of the data that is in the customer's data table. And here we're in this IDE. An IDE is pretty much what you call a tool that you use to develop code in. And so this is the IDE provided to us from ProgramIs. They're not sponsoring this video or anything. I just like to use it because it's a nice free to use tool that already has data available to work with. So now we're going to click this blue button up here that says run SQL. Boom. Look at our output. We have pretty much replicated the data in the output that matches the data in the customer's data table. And so what we did here in the IDEs is we said, get all of the data from the customer's table. And that is what was returned to us. All of the data from the customer's table. You see we have the 5 variables, customer ID, first name, last name, age, and country, and the 5 rows of data, which is customer ID 1, 2, 3, 4, 5, and the corresponding variables with it. Now, say that we didn't want to get all of our data, because generally in best practice, you don't want to select all of your data. You only need some of the data in the data table. So let's say we only really care about the customer ID and the first name. So what we do in our SQL is we erase the all and we write customer ID exactly as it is spelled in the customer's table. And then we're going to do a space, a comma, another space, and we're going to write first name. And what this is doing is it is just specifying the 2 columns that we want to access from that customers table. And hopefully this should return to us only data from the customers table that matches the columns in customer ID and first name. So let's give that a run. Boom. Look at our output. We have customer ID and the first name. 1, 2, 3, 4, 5, John, Robert, David, John, Betty. Great. So now that is how you use select. You can either select all of your data or you can select just a few columns that you want from your data table to produce a smaller subset of the total table. Okay, great. Now let's add our first bit of logic here. So we have customer, first name, and there also is a variable called age. So let's bring in age and we will run that again. Boom. Now we have customer ID, first name, and age. Now, let's say that we only want to get customers that are older than 23. So you can see we have customers of ages from 22 to 31. But now say that we only want to look at customers that are older than 25. How can we do that? That is where the where clause comes in. And so the where clause is one of the most powerful clauses in SQL that you can use to filter your data from your data table. And how does that work? Well, now we're going to write after from, we're going to write where age is greater than 25. Okie doke. Let's give that a run. And boom. Now that returns only the data of customers where the age of the customer is greater than 25. Pretty cool. But hey, it looks like John here, John Reinhardt from the UK, is exactly 25. But in our run, in the output from our data run, John Reinhardt did not come out. Why is that? Well, that's because we used the greater than symbol. So with where, you can use a whole bunch of operators with where to specify exactly what you want. Because John is 25 and we use the greater than symbol, we're saying only return customers where the age is greater than 25. But if we want to include John Reinhardt in this, we would then say where customer is greater than or equal to 25. So let's give that a go. Boom. Now you can see we have 2 Johns here. As a matter of fact, let's add last name too so we can determine that. Boom. Now we have John Doe, who's 31, and John Reinhardt, who's 25, both accounted for here. Great. Now you see that we have age included in the select statement. A common early question is, do you need to have the variable in the select statement that you also want to use in the where clause? And the answer is no. So watch this. We're going to remove age, rerun the data again, and boom, it's the same result. So you can filter on a variable or filter on a column, and you don't need to bring that column in with the select statement. Similarly, if we want to just get data from our table that is equal to a specific value, we don't need to use a greater than sign. We can just say equals. So let's see that I can see here that we have somebody, Betty Doe, whose country is the UAE. Let's say we only want to look at customers who are from the UAE. We can adjust this by going into the code, deleting the greater than, and then just changing the age variable to country. Additionally, we're going to delete 25 and replace it with UAE. Now, this query should return us the customer ID, first name, and last name of all customers in our customers table whose country is equal to the UAE. So let's give that a go. Run. That didn't work. Now, that's a common error in SQL. And why didn't that work? Well, the reason why that didn't work is because the UAE is a string variable. We need to specify in the where clause that the variable we're filtering for is a string variable. And the way that we do that is after we say where country equals, we're going to put quotation marks around the UAE. And give that a go. And boom, we just have Betty now. And you can see up here in the left-hand corner, these blue words indicate what type of variable is, or what the data type of your data is. And so you could see age was an int or an integer. That means a number. You can see that country is a varchar, or a varchar, which basically is a string. That is basically text. And the way that we can interact with text is by putting quotation marks around it so that the code interpreter knows that we're referring to the country text-based value of the UAE. Because really, these every entry in the cells here, these are data values. They are pretty much like the data that you enter in your Google Sheet or your Excel file. These are the values of your data. And the value of the age data is a number, but the values of the country column are varchars or strings. And so if we want to reference a specific varchar, we need to put it in quotation marks to let the code interpreter know that we are referencing a string. Great. So let's delete that where clause, run our data again, and this should bring us back to the total data set of the customer's data. So we have 5 customers here. Great. Now, one other really interesting clause to use in SQL is called the limit clause. And what the limit clause does is it only returns the top X rows that you ask for. So we have 5 data points here in the customers table. Let's say we only want to look at the top 2. The way we're going to do that is we're going to write limit 2. So we have the same syntax as before. Select customer ID, first name, last name from customers, and the new thing we've added is limit 2. Instead of returning all 5 rows of data from the customers table, this now should only return 2. Let's see. Boom, perfect. It returned Robert and John. And you may be wondering, hey, why did it return Robert and John? Why not another pair? Well, by default, limit will return the top 2 rows in the way that they are ordered naturally in the database. This is the very basics of SQL. This is how you get data from your data table, how you point to which data table you want to get data from. You can filter on that data, and then returning only the X number of rows that you want with the limit function. So we've covered select, from, where, and limit. Great. Now let's get a little bit more complex. Now let's work on aggregations. Okay, so aggregations are super common in SQL, and what they are is basically, say you want to get the sum of certain value in your data table. You can do that by aggregating your data using new clauses in SQL, and you can get totals and summary values to summarize the data in your data table. It basically adds up all of the data that is of the same type to return a sum or a summary per each value that you specify from your data table. So let's try that out. Okay, we were working with the customers table. Let's now work with the orders table. So we'll start by looking at the data in the orders table, starting with a select all from orders. Run that data. Boom. We have 5 rows of data in the orders table. Okay, we have order ID, item, amount, and customer ID. Great. So I see that in items, we have a bunch of different items with different sale amounts. A very common question that you could run into in SQL is, or in data analytics in general, is how much did a certain product sell? And let's answer that question here. So the question that we're going to do is, what is the value? What is the total value of each item sold? So we have 5 rows of data, but we only have 4 distinct products that were sold. And you can see that a keyboard was sold twice. And so let's say we want to get a summary of the items sold, which shows item and the total revenue from all the sales that we have in our orders data table. The way that we do that is we're going to use an aggregation operator and a group by. So let's get going. We start off pretty simple. We start off by saying select item, amount from orders. These are the 2 columns that we need to operate on this now. Okay, we run that and boom, we just have those 2 columns. Now we need to aggregate these columns. And we want to aggregate these columns on the item. We want to get the total sales per distinct item in the orders table. So the way we do that is we do sum amount. Great. And sum here means we're going to sum up the amount column for all items of the same type. Now we need to specify what we're going to sum up by. So generally, we're going to sum up by the item. And the way we indicate that in SQL is via a clause called, or a function called, group by. So after from, we're going to say group by item. Okay, let's give that a go. Boom. Great. Now you can see instead of having 5 results returned, we only have 4 now. We have keyboard, monitor, mouse, mousepad with the totals associated with it. You can see now that the keyboard is a total of 800, whereas in the orders table, the keyboard has a sale here for 400 and another sale here for another 400. So the sum together is 800. Great. Now in aggregate functions in SQL, you can also filter that data too. So we can also use the where clause here. So say we only want to look at the data that has a monitor item sold. So the way we're going to do that is we go back from orders, so between the from and the group by. So it's going to be below the from, but above the group by, we're going to write where. And now we're going to say where item is equal to monitor. Don't forget your quotation marks. And we're going to run that again. And boom. Now we only get the monitor item returned to us. Great. That's exactly what we wanted. And so if you're following along live, boom, congrats. You've done your first aggregation in SQL. And aggregations are kind of the baseline of working with SQL data all the time. I do probably hundreds of aggregations a week just working with SQL. So let's get a little bit more complex now. We'll start by deleting the where clause. And you can see, aside from sum, let's add a column to count how many items of each type were sold. So we had 5 total items sold, but we only had 4 distinct items because keyboard was sold twice. But now let's say we want to indicate that in our SQL code. So after sum, we'll do an enter, a comma, and we will write count item. And what this is going to do, it is going to count the number of times that an item appears in the item's dataset. So just watch. We'll run it, and boom. Now you can see we have keyboard, the sum 800, and the count 2, because we sold 2 keyboard items in the orders table. Great. You can also now see that the aggregation columns we made, the sum and the count columns, they kind of have ugly names in the returned output that we get. And you can change that. The way that you change that is you can actually specify the name of a column that you want. So the way we're going to do that is after sum, we're going to say space as space, and we'll just call this revenue. And then for count, we'll say after item, do as item sold count. I'll run that again. And boom. Now you can see we have much cleaner variable names in our output. We now have item, revenue, and item sold count, which is better than the default names that come from SQL aggregation functions. Okay, great. We are doing so good now. But now here is a key concept in SQL, a key concept in coding in general that is super important, especially in data analytics. And now let's focus on joining, because you can see here that we have 3 data tables: customers, orders, and shipments. And so far, we've been only working with an individual data table. However, to make really good analyses, we need to be able to join data from one table to another to create a super rich data set that we can do analytics on top of. And the way that we join 2 different data tables together, 2, 3, 4 can be as many data tables as you need, is using the join clause. So let us do that. Now, the first question you might have is, how do we join? And this gets into the concept of primary keys and foreign keys. So, put my glasses back on for this one. You can see in the customers table, we have a customer ID. The customer ID is our primary key for the customers table. And you can see in the orders table, we have another column called customer ID. That column name matches the column name from the customers table. So the customer's customer ID is the primary key, and we're going to use the customer ID in the orders table, we also call that the foreign key, to join the customers table to the orders table so that we have customer information and order information in one data table together. So the way that we do that is, let's just begin simple by saying select all from customers, delete the group by, join orders. And now we need to specify the columns that we're going to join on. So we're going to join the customers table to the orders table on the common column customer ID. So we're going to say join orders on customers dot customer ID is equal to orders dot customer ID. And what this is doing is, this is super powerful in SQL, and kind of the backbone of a lot of work you will need to do in the future in SQL is, it is taking the data from the customers table and finding where there is a corresponding ID. That corresponding ID we're using is the customer ID in the orders table. And so it's going to return to us the output of all the customers and orders that have a matching ID in the customer column. So let's run. Boom. Now you can see that we have 5 rows returned to us, but we only have 4 distinct customers that got returned to us. We have the customer ID 4 comes back 2 times. And the reason is because the customer ID 4, who is equal to John Reinhardt from the UK, had 2 entries in the orders table. So it looks like John Reinhardt bought a keyboard and a mouse for $700 in total. $400 for the keyboard, $300 for the mouse. Big baller. Now you'll notice that Betty does not have anything returned. And the reason is because Betty, who is customer ID number 5, does not have a corresponding customer ID in the orders table. So while Betty is in our customers table, it looks like Betty doesn't have an order in our orders table. And so natively, if you just write a join statement in SQL, acts as an inner join. It only returns to you data that has a match in both tables that you are referencing. Now let's say that we wanted to include Betty in our returned output, even though she doesn't have an entry in the orders table. There are many different types of joins in SQL. So the native one is an inner join that gets data from both tables you're referencing, the parent table and then the table you're referencing via the foreign key. In SQL, you have 4 types of joins. You have an inner join, a left join, a right join, and an outer join. For the most part, though, for like 90% of work you'll do, you'll only really end up using the left join and the inner join. So natively, we've inner joined from the customers table to the orders table. But if we want to include Betty, who is in the parent table that we're using that has the primary key, we're going to say left join. And so check out this graphic here. Boom, that describes the joins. And what we're doing by saying left join is we are going to get all of the data from the first table, customers, and join in the data that matches on the orders table. So in left join, that means get all of the data from the first data table you're referencing. And the first data table you're referencing is the data table that comes directly after the from statement. So now we're going to get all of the data from the customers table because we're using the left join and join that to the orders table via the corresponding matching customer IDs. Okay, let's run that again now. Boom. Now you can see that Betty is here. However, for the referenced orders table in association with Betty, we have blank values. And the reason we have blank values because Betty does not have a referenced customer ID in the orders table. And that is a quick snapshot on joins. Inner join, left join being the most common that you do. Inner join being getting data that matches via a similar column in both data tables. And so left join is getting all of the data from the first table and only joining in the data from the second table that has a matching ID in the first table. And if there are entries in the first table that don't have a corresponding value in the second table, it will return blanks or more commonly nulls in the output when you do the join statement. Now let's say, hey, Betty actually does have an order. It just wasn't ever entered into the orders data table. We can manually add Betty's order to the orders table. And the way we're going to do that is using an insert statement. So what we're going to do is delete all our code and say we're getting started with inserts. And we're going to write insert into orders values space in parentheses. This is going to be order ID 6. Let's say Betty bought a mouse for an amount of 200 and the reference customer ID of Betty is 5. Boom. After we run that data, you can see now there's a new entry in the orders table that has Betty's new order in it. And so if we do a select all statement from the orders table, Let's run that again. We can now see that there are 6 data rows in the orders table because we have added Betty's mouse purchase to the orders table. And now if we go back and rerun the left join statement, joining customers to the orders table, Betty should now have valid entries for her corresponding order data. Let's give that a go. We're going to run the exact same SQL as we were doing before. And boom, yeah, there is Betty with her mouse for 200 because Betty has a customer ID foreign key reference in the orders table that matches her customer ID in the customers table. And a primary key you can kind of think of is an index for a data table that you're starting with and joining other data tables to. And a foreign key is a reference ID that matches the primary key in the starting data table that you're working with. So great, we've done a bunch now. So we have general select operators from, we've filtered with where, we've limited, we've aggregated using sums and counts, and now we've joined multiple data tables together. I think the last step that we're going to do is like a real live data analytics problem that you might get on a job if you're working with this type of data. So let's do that. Okay, so let's say we're given the question, which customers do we need to update regarding their order if their order is not yet delivered? This could be a very common question. I get this sometimes all the time working with ecom data. And so basically we want to identify customers that we may want to reach out to if their order is not delivered yet. For example, say it could get lost in the mail or something happened, but for whatever reason, the customer's order has not yet been delivered. And so we may want to, as a business, proactively update that customer that their order may be late. And so, using these data tables here, we want to identify which customers do we need to update. Great. So we will start by working with our shipping data. So we're going to say select all from shippings. Boom. So this is our shipping data. We have multiple statuses: shipping ID, status, and customer. So we only want to start working with the data where the status is not delivered. The way we can do that is we'll add a where clause. Then for saying not, we will say exclamation mark equals. This is a SQL operator that means not equal. So we're going to say not equal to delivered. And because delivered is, boom, see, that didn't work. And that's because I didn't reference the column in the shippings table that we want to perform that not equal to function on. And that column that we want to perform that not equal to function on is called status. So we're going to say where status is not equal to delivered. Give that a go, and boom. So now, instead of the original 5 data entries in the shippings column, we only have 3. And so we have a customer column here that looks like a foreign key to the customer ID column in the customers table. So let's try to join the shippings data to the customers data using the customer column in shippings equaling to the customer ID column in the customers table. So what we're going to do now is from shippings, join customers on shipping dot customer. What we're doing here is we're saying in the shippings data table, reference the customer column, and then we're going to say equals in the customer data dot reference the customer ID column. The way that we reference a column in the data table when you're doing a join is shippings dot customer. So you're referencing customer, the customer column in the shippings data table. And we're still going to select all for now. And let's run it, and boom. Oh, looks like I spelled customers wrong. You need to make sure when you're doing the join that the data table you're joining on you've referenced correctly in the on part of the query. So it can be kind of long, and there are ways around it, but let's start by doing the long version with the updated customers table spelled correctly now. Run it, and boom. But yeah, that is kind of long. There's a way that you can get around this using an alias. And so the way you do that is after shippings, you would do a space S, and S is going to reference the shippings table. Basically just call it an alias, and we'll call customers space C. So C, the character C, is going to reference the customers table. And so now we can delete this word shippings, write s.customer, delete the word customer, and write c.customer ID. And we should be able to do the same exact join without having to write out the full name of the data table. Yep, boom. Okay, so it looks like we have Robert Luna, John Reinhardt, and Betty Doe. But now we have a whole bunch of like IDs with us. We don't want all of that data. We only want the customer's first name, last name, and status to reference their status. Boom. Okay, great. But now say we want to make this a little bit more complex. Say that we want to also see when we reach out to them which products they purchased and how much they spent with us. We're going to adjust the question, specify the products and total revenue from the customers we need to reach out to. Okay, so now we need to get the data from the orders table. And so the way we'll do that is we will join orders O on O.customer ID equals S.customer. Boom. But now, because we didn't enter any of the order data, we don't have any order data, but we have John Reinhardt entered twice. And the reason is because we're doing an inner join between shipping and orders, and because John Reinhardt, customer ID number 4, has 2 entries in the orders table, he's coming up twice now in the output. And because John Reinhardt has 2 entries in the customers table, the 4 customer ID number 4 comes up twice. On the output, he has 2 entries as well. And so that means we'll need to do some aggregation at the end to make a simpler output, because generally we don't want to, if we just need to provide a list to, say, the help team to reach out to the customers, we don't want to enter his name twice. We don't want to enter John twice. We'd only want him to show up once. And so we can fix that using an aggregation. But first, let's bring in the data, the item, and the amount. And really, in good practice here, we should specify in our select statement which variable is coming from which table. And the way we can do that is using the same alias that we applied earlier. And let me show you why this is important. Like, say we want to add in customer ID. Should be pretty simple, right? Boom. Ooh, error. Ambiguous column name customer ID. And the reason why we get that error is because customer ID is the same column entered in 2 different data fields. So the interpreter, the SQL interpreter, doesn't know which customer ID we are referencing. So it is always best practice to reference the data table of each variable in your select statement when you're joining multiple tables together. And the way we do that, we have S representing shipping, O representing orders, and C representing customers. So we can just assign C dot for first name, C dot for last name, S dot for status, O dot for item, O dot for amount. And let's say we're using the C dot customer ID. We'll run that again, and boom. Because we entered the data table reference, the SQL interpreter knows exactly which customer ID column we are referring to, the one in the customer's data table. Okay, great. So now we need to summarize this data to make a nice little output that we can send to the team member that needs to contact these people to tell them that their order is late. How do we do that? Well, glad you asked. Let's start by doing a count of the items. We'll do a sum of the amount. And generally, I never like to have non-aggregated columns come below columns that I'm aggregating. And because I'm going to be aggregating item and amount, let's move up customer ID to the top column, just to avoid confusion. Okay, now do you think this will work when we try it to run it? Let's give it a go. Boom, it did, but it only returned 1. And sometimes, depending on the SQL interpreter you are using, it won't return anything whatsoever. The reason why this occurred is because we didn't specify what we want to group by. Because we didn't specify what we want to aggregate on. So we want to aggregate on the customer. So we're going to say group by, below the where, customer ID, and run that again. And boom, now you can see we have Robert, John, Betty, only 3 results. We have their first name, last name, status. We'll call this as order status. We'll clean up some variable names here. We'll call this amount as items ordered. And we'll call the amount as total revenue. Just to make it be super clear to whoever we're passing the data on to next, what is being represented here. So we'll run that again, and boom, that is an output. Now this is almost good to go. Let's say we want to order the data by the customer who spent the most with us. The way that we can do that is using another clause called, now let's say that we want to order our output of the data in order by customers who spent the most amount of money with us. And the way that we can do that is by adding a new clause called order by, and this is going to do exactly what it sounds like. It's going to tell the SQL interpreter to order the output by a specific column that you reference. And the column that we're going to reference here is total revenue. And we can even, after this, tell it which way do we want to order by, descending from highest to lowest, or ascending from lowest to highest. And so I wanted to order by the customers who have spent the most money with us. So we want to order it by the descending. So the most revenue, second most revenue, third most revenue. And the way that we can do that is by a SQL command called DESC, short for descending. And so this is going to tell it to, this new code is going to tell the SQL interpreter to return the results ordered by total revenue from highest revenue first all the way to lowest at the bottom. So we'll run that. And boom, yeah, we have 700, 250, and 200, which is exactly what we wanted. We could also change this to ASC, which would be ascending. And so what we should expect as a result is the data ordered from lowest revenue first and highest revenue at the bottom. Try that. And yep, 200 is first and 700 is at the bottom. But let's keep it in descending. And boom, this is exactly the output that we could then give to somebody on the happiness team or in the help center team to say, these are the customers who have not yet received their order. Maybe we should reach out to them and say, hey, sorry, your order is going to be late, or your order is still in transit, it's not yet delivered. And boom, there we go. That is a real life SQL problem that is pretty common. And this is a situation that I've worked with many times in the past before. And that, my friends, is a quick overview of SQL. We might have gone a little bit beyond 20 minutes, definitely more than 10. But I hope now that you feel like you have a decent grasp of the most common functions in SQL and how to use them. I recommend go to this website, programiz.com. There's a whole bunch of other ones too, SQL Byte, and practice doing your own problems here for free. You can use these SQL editors and the data that is already available and make your own analyses that you could then use to make your own data projects and continue your learning too. So, SQL is a blast. To be honest with you, these commands that we just used are pretty much like 80% of all that you will need to know about SQL, writing the code. There's a lot more to it, and there's a lot more kind of advanced functions that we'll get into in the future. But to begin with, this is kind of like the baseline of everything SQL. And you should be able to now, feel free to watch this video again and again to get some refreshers over certain sections. But after covering aggregations, filtering, ordering, and joining, that is like 80% of what you will need to do in SQL. And so the next step is just practice, 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 practice. I'll be making a ton more videos on SQL and doing more in-depth live analyses. So I'd love it if you found this interesting. Subscribe. There's going to be a lot more content coming. I really enjoyed making this video with you guys. I hope if you're just starting out that you learned something, that this is kind of interesting. And even if you're not a beginner, maybe this is a little bit more of a good intro for getting a little more hands-on with using SQL live and then answering a live business problem using SQL. So hey, I hope you liked the video. I enjoyed this one. I hope you learned something, and I will see you in the next one.